good afternoon, chemistry, or morning, depending on when you're watching this. So I'm going to take you through the notes here. Fourth block, I know we got the first side of these notes, so feel free to tune out for a minute or look back over, just follow along with the stuff that you already have. So we're going to talk about the mold today. We've talked a little bit about it. You guys made some awesome molds. So I have mammoth mole or the woolly mole, and then I have the Hulk mole here today to help me do my video. Okay. And I decided I'd let you see my face since I know you guys are missing me, and I am sorry that I'm out of the classroom so much. It'll hopefully slow down and be better after this. So let's talk about the mole. Remember, it's a unit of measurement. It's not an actual like hairy, furry mole. It is a unit of measurement, a way of grouping atoms together. So we use it to measure particles, and particles are very, very small. So that's why we require a large number. So 1 mole of anything is 6.02 times 10 to the 23rd particles. Now what the particle is will determine the mass itself. So like this is 1 mole of sugar and this is a mole of salt. Obviously same amount of particles, but the particles are very different between these, and we'll talk about that here in just a second. So it's also called the Avogadro's number. Avogadro was the scientist who came up with the concept of the mole. He didn't come up with the actual number. Later on, when that was discovered or determined, they attributed to him for his ideas on gases and pressure and how we can have the same amount of something. Okay. So why do we need the mole? We use it just like we use the dozen. So if I say a dozen, you know that I mean 12 eggs. When you say a mole, I know that you mean 6.02 times 10 to the 23rd particles. Now again, that mole doesn't mean that they're all the same size. So this is a mole of carbon. This would be a mole of sulfur. Carbon has a mass of about 12 and sulfur about 32 grams. Okay, so mole, but different masses. 1 mole of sodium is 6.02 times 10 to the 23rd atoms of sodium. So let's talk about representative units. And again, you can pause this video. I'm going to go kind of fast. I'm not going to wait to write down. So just pause it, write it down, and then we can keep going. So let's talk about representative units. This term means the smallest piece of a substance. Now that small piece might be a different size when we compare like atoms to molecules. So let's talk about that. Molecules, that's what sugar is. It's a molecule. And the formula for sugar is C12H22O11. So let me put that up here really quick. So, here we go. Working? Yeah. C12H22O11. Okay. Well, this is a mole of sugar. That's a big molecule. That's 12 hydrogens and 12 carbons, 22 hydrogens, and 11 oxygens make up just one molecule. Where something like this is salt, table salt, which is sodium chloride. So if I write that out, that's just 1 sodium atom and 1 chlorine atom or chloride atom. So the size of each particle is very different between sugar and salt. That's why sugar is so large and salt, 1 mole isn't that much. Same thing if we think of sugar versus carbon here. Again, so this would be an atom. This would be an example of an atom. Sulfur here would be another example of an atom. All right. So just because we have a mole of something doesn't mean the mass is the same between them. A formula unit is when we have an ionic compound. Salt is an example of that. It's when a metal bonds with a nonmetal. For other elements or all other elements, it's going to be an atom. So sulfur, these are atoms. There's 6.2 times 10 to the 23rd atoms in here. And for carbon, same thing. There's 6.02 times 10 to the 23rd carbons in that container. All right, so we use them to describe things. So 1 mole of CO2 would be 6.02 times 10 to the 23rd molecules of CO2. We use it just like we use the atom. Just depends on what we're measuring. Here's some more examples of that. So numbers of particles, it's all going to be 1 mole, but the particle size is different. So if we were to mass it out, it's going to be different. Here's kind of the big thing we need to take away. How do we use the mole as a conversion factor? So if I handed you this vial full of sugar and I said, how many atoms, or not atoms, sorry, how many particles of sugar are in here? How many molecules of sugar? You could figure that out using this conversion factor. You know that for every 1 mole you have 6.02 times 10 to the 23rd particles of something. So let's do an example problem. And I would encourage you just to jot this down in your notes. How many molecules are present in 0.5 moles of carbon dioxide? Okay, so let's see here. We're going to start. Let's take a look here. We start with what we know. So I know that I am starting with 0.5 moles of CO2. Sorry, that formatting got a little bit mixed up. Let me get back there. And then I'm going to, if my moles are on top of the fraction, then they have to go on the bottom. So 1 mole would go on the bottom so that my moles would cancel out. And then 6.02 times 10 to the 23rd would go on the top. So my moles cancel out here, and I'd be left with CO2 molecules or molecules of CO2. So that's my desired unit, and I wanted how many molecules were present. That's what I want. So I took 0.5 times 6.02 times 10 to the 23rd divided by 1, and you get this number. But you'll notice we have to always think about sig figs. So I have 1 sig fig here, 3 sig fig here. We can ignore the 1. So my answer can actually only have 1 sig fig. So I'd want to drop off that 0.0. All right. So your homework today is just going to be one-step problems. All right. So let's do another example. I think I got to get my pointer out for this. So how many atoms, so we're looking for atoms, are in 2 moles of aluminum? Okay. So I'm starting with moles. So 2.0 moles of aluminum. Okay. Now I know my conversion. I know that 1 mole of anything is equal to 6.02 times 10 to the 23rd. So if my moles are on top, I want to get to atoms. Moles are going to go on the bottom. The 1 is always going to go next to the moles in this conversion, and the 6.02 is always going to go next to the atoms. So 6.02 times 10 to the 23rd, and it's aluminum, so I'd put atoms. Please excuse this terrible, terrible writing. So when I calculate this, I'm going to go 2 times, if you're using one of my calculators, remember you're going to use the EE button. So 6.02 EE, that's that button right here. EE is the times 10 to the 23rd. So my answer then comes out as 1.2, and I could have 2 sig figs, so 2 here, 3 here. 1.2 times 10 to the 24th. And it is common when we're converting from moles into atoms, your number is going to be large because there is a lot of atoms in a single mole of substance. Okay, let's do one more and then we'll be done. How many moles of sulfur are in 1.8 times 10 to the 24th sulfur atoms? So how many moles of sulfur are in 1.8 times 10 to the 24th? So I want moles, and I'm starting with atoms. So 1.8 times 10 to the 24th atoms. Wow, can't do cursive. Atoms of sulfur. It is a good habit to write what your element is. So now atoms are on top, so they got to go on the bottom. So 6.02 times 10 to the 23rd atoms would go on the bottom. Wow, I apologize. And then 1 mole goes on top. Your atoms are going to cancel. So then I could divide 1.8 divided by 6.02 to the 23rd. That's going to give us, I can keep 2 sig figs, so actually it's 2.99, so it's going to round to 3.0 times 10. Oh, let me recalculate this. 1.8 to the 24th divided by 6.02 to the 23rd. There we go. Sorry, this messed it up. So my answer is just going to end up, I can keep 2 sig figs, so it's just going to be 3.0 moles. Okay, 3.0 moles of sulfur is what we end up with. All right, so hopefully that's helpful. Your worksheet or your assignment that you're going to get is just one-sided, and it's just these starter problems. All right, feel free to email me. Let me know if you have questions, and I hope this was helpful. All right, see you guys later.